Okay, and we're back. If you hear me talking to the digital assistant of Windows, I can do that with voice on the HoloLens or actually using hand commands. But here we are, we're back. These are vectors. Back we have Nellie Newton. She's pulling on the sled with a dog. She has a rope, so essentially she's pulling on a rope. But since it's at an angle with the horizontal, which we could call theta, this force actually has two parts, as you could see. This is the overall force, but it's a part that actually pulls the sled, which is labeled force X, and a part that doesn't pull the sled, which is in the Y direction. And in this case, because the angle is shallow, the X component is greater. All right? And their book asks, what other two forces act on the sled? All right? And of course, because of the dog, they would be the weight of the dog and the sled, or the force of gravity on both of them, and the normal force up, and they would be equal. In physics, we call these type of drawings free body diagrams, because most of us, myself included, are lousy artists. Instead of drawing this picture, we'll just simply draw the forces on, in this case, the sled by drawing a dot. Okay, and the ones we care about are the only ones that are important. And in this case, even though there are two forces that make up Fx and Fy, we really only care about Fx because that's the way the sled's going to move. So in this case, we could draw an arrow for Fx, which acts on the dog and the sled, but we also have to include the force of gravity on the sled and the dog and the normal force. Okay, and so this here would be a free body diagram there, showing the forces on the dog and the sled. A force this way causing it to move, the normal force because of the pushback, and the force of gravity. Hey Cortana, go home.